All right. Good day, class. I'm still Mr. Toby by name, and right before me here, we're going to be discussing on electric field. Now, when we talk about electric field, I want us to actually break this concept into two parts. We have the word field. As we all know, we know that when we talk about field, what comes to your head, as I can actually think for you, is that what you're talking about football. Now, when you talk about field in physics, the word field means the region of space. The region of space. When you talk about field, is a region of space whereby something can be experienced. Now, a region of space whereby a force is experienced. Now, when you talk about field in physics, you talk about a region of space whereby a force is experienced, as you can see written on the board. Please, I want you to write it down. Now, for you, you actually know that when you talk about football field means that a region of space whereby you play football, or football is experience. You can put it that. So whenever you say the word field in physics, one thing to occur in your mind is a region of space whereby a force is experienced. And we have types of field in physics. We have the electrostatic field. Electrostatic field. We have the gravitational field. The gravitational field. And we have the last one as the magnetic field. Magnetic field. So it's something that you don't need to craft. So whenever you want to define it, you know that it's a region of space whereby electric force is experienced. It's a region of space whereby gravitational force is experienced. It's a region of space whereby magnetic force is experienced. So it's not something that you should actually start cramming. So when we but the topic here, we're going to be looking at electric field. So can someone write out the meaning of electric field for my explanation? This can be defined as a region of space whereby electric force is experienced. And you get your full mark. So you should note that two things. It's a region of space, and there is a force that must be experienced in that region of space. That is why it is called a field. Something field. Because of there is a force that must be experienced. Like now we are talking about electric field, we talk about electric force. When we talk about gravitational field, we talk about gravitational force. Now, we want us to look at some things that applies under electric field. We talk about field lines. Field lines. I'm trying to take you back to your SS1 so that you can have a good foundation before we move from there. Now, when you talk about field lines, what are field lines? Field lines are imaginary. They are imaginary lines that are drawn to describe the behavior of a field. They are imaginary lines. Now, you are not seeing them. You are not seeing these lines. They are imaginary lines drawn to describe the behavior of a field. Now, from here, I will actually give a respect to Michael Faraday, who actually come up with the field line. He said it's an imaginary line, although we're going to be still talking about the properties of field line. So I want you to write it down. is they are imaginary lines. They are imaginary. You just imagine them. Imaginary lines that are drawn to describe. I will still give you something to describe a behavior of fields. So you should know that when you talk about field lines, we have it as imaginary lines that are drawn to describe the behavior of fields. Now let us look at another word that we are going to be using frequently: electric charge. What are electric charge? What are electric charge? From the word electric charge. This is a charge that generates the electric fields. They are charged. They are charge that generates electric fields. I want you to write them down, because when I start explaining and using those words, you will not be found wanting. And we have two types of charge. We have the what? The positive charge and the what? The negative charge. We have the positive charge and we have the negative charge. Now let's take it one after the other. The positive charge. What are positive charge? What are positive charge? Now we told you that what? Charge generates what? Electric fields. So now we want to look at what positive charge are. Let me just give you what a positive charge looks like. Please, you need to note the arrows. The arrows are really what? Necessary. You need to note the arrows. Now, as you can see, the arrows is going out. Is going out. Is going out. As you can see, these lines are indicated as what? The what? Field lines. Or you can call it what? The electric field lines. And we have the charge, which is what? A positive charge. You can see it's generating what? It's generating field lines. It's giving out what? Lines. But it's not taking in. Look at the arrows. You must note the arrows. Now let us write. What is a positive charge? A positive charge. Please write it down. This is the source of what? Electric what? This is the source of electric fields. They are source of electric fields. They are source of electric field. Meaning that what? Electric field lines actually what is generated from, it's originated from the positive charge. They are source of electric field. Now let us look at negative charge. Negative charge is drawn like this. As you can see, this drawing I'm drawing, we call it what? In higher level, we call it what? I think in your level 2, we call it what? An isolated charge. An isolated charge. These are isolated charges. As you can see, a negative charge is actually taking in, see the direction, taking in field lines. A negative charge is taking in field lines. So it can actually be defined, negative charge can be defined as what? Where the field lines terminate. Where they actually terminate. This one is what? Originated from. What? They originate what? The field lines. Why what? The field lines here, what? They get terminated. Meaning that when they come to this point. So these are all called what? Isolated what? Charges. Charges. So you should know, when we talk about isolated charge, we talk about positive charge, they are isolated, it's on its own. Negative charge on its own. And you indicate by what? By drawing out what? By drawing out their diagram and their direction. Their direction is really very important. Now, let us look at the pair of two charges. Now, when we talk about pair of two charges, let us look at what happened there. This actually takes us to the law of electrostatics. What is the law of electrostatics? It states that what? Like poles will what? Can I write it? Let me write it down. Laws of electrostatics. A lot of you say it a lot. Electrostatics. Which states that what? Like poles, like charges, sorry, we are not using poles now. When we are using poles, we are talking about what? Magnetism. So, like charges will what? Like charges will what? Repel. While unlike charges, will attract. I'm trying to define all these terms so that whenever we are using it, you shouldn't actually what? Be confused. So the law of electrostatics says that what? Like charges will repel, while unlike charges will what? Will attract. Now let us look at what they are trying to say here. That's actually when we have the pair of two charges. Now we have what? A positive charge and we have what? A negative charge. Now what happens? There's an attraction because of what? Unlike charges will what? Attracts. They will attract from the law of electrostatics. So as you can see, they are attracting. But you can't draw this in an exam hall and you expect to have your full mark. You have to what? Indicate the direction. The direction of what? The direction of the electric field lines. Now, as you can see, from what I told you previously, I said that what? The positive charge is what? Is giving out what? Electric field lines. It's giving out. So let's indicate it like that. It's giving out. It's giving out electric field lines. So as you can see, being indicated. Giving out. So what happens to the negative charge? It terminates the what? Field line. So the field lines terminate in itself. So when it goes, it comes here to be what? Terminated. As you can see, taking in the what? Electric field lines. As simple as that. Taking in the electric field lines. As you can see, so unlike poles we what? They will attract. Now let us go for what? Like poles. When we have what? Positive, they can ask you that you should actually indicate by what? Drawing what? The pair charges. The like poles and the unlike poles. Please permit me, I want you to use your what? To use your ruler. As you can see, they repel. Very simple. So this one is giving out, and this one is also giving out. Because it's what? Positive charge. It gives out electric field lines. Simple as ABC. Giving out. So, under gravitational field, they will tell you that what? The Earth itself is what? Negatively charged. That is why what? Any object that is any object that attains a particular height from the earth drags it out from what? Gravitational force. Then when we get there. But you should understand that what? Light poles what? Repel. Light poles what? Repel. While unlike poles what? Attract. From what? The law of electricity. I know that you students understand this very well, but you just don't know like what law of electricity. So from the next class, we're going to be looking at what the properties of what electric field lines. The properties of electric field lines. Please, I want you to know that and draw these down. Thank you very much. See you in part 2. Thank you.